session post lunch is a little difficult to concentrate on, but a high tea might have charged you up. So still we will try to keep our talk as crisp as we can. So this is the introduction that Riaz has already given. So we might skip on that. Agenda. Allow me to walk you through the agenda of our today's topic. Introduction and some details. Here we will be dwelling up with some basic definitions that will be used in Wi-Fi networks. Then some modes, some basic details that might help us to understand the topic in better depths. Then the evil twin, our core topic of discussion. Here we will see what exactly evil twin is, where it came from, or where to find it, and some basic details on that. Then first packet approach. This is our approach that we have devised, and we'll be providing details on this. This might be an exhaustive talk, I must say. Then the things we learned in this excursion of learning about evil twin. We have stumbled upon many cases. We have faced many issues, and we'll be discussing those here because if somebody might want to replicate this experiment, they can save this. They can save the time on that experiment. Related work. Yes, there are approaches available presently, but they have certain kind of limitations. I'm not saying our approach is better or worst, but this is a different approach for a different set of audience, and we'll be discussing in more detail upon the other approaches. Those are present. Then potential approaches. In this topic, we have actually found the avenues, the places where we can find more approaches to detect the evil twin. Conclusions. Yes, we had to have conclusions, and we have it. Acknowledgements. So introduction and some details. Rushikesh will be elaborating more on this.
Hello all. This is just going to be some overview for this particular topic on introduction and some definitions. So I won't speak anything on that. Let's go to the slide. What .11 is blamed for? Basically, whenever we call it's in wireless network implementation, yes, people, they think, okay, yes, can I hack it this way? Can I mess up with this and that and whatnot? Well, yes, it's been badmouthed for quite long now. Yes. Before we proceed further, I just wanted to make sure, the context of discussion here is open wireless networks, okay, and not any privacy and all those details. All right. So hole in the parameter, a hole in the network parameter they call open wireless networks. Yes, poor implementation of WEP, bad configs. Abhijit have actually elaborated a lot on that part in prior session. Then yes, loose link into the client security. Offensive rogue access points, yes, there are possibilities there could be some captive portal asking for a particular detail to be injected, and once you inject those particular detail, it might send you back some malware and whatnot. There are a number of possibilities we can dwell upon. Eavesdropping in socially dense areas. This is one of the core most concern that is being faced by the people who are working on WIPS or WIDs. Connectivity mess ups, yes. Usually this is what happens whensoever there is an overriding of RSSI. Like usually what attackers does, they try to take over the channel, or they try to take over the communication by suppressing the existing channel's presence by increasing their dBi gain of antenna. So a lot of mess and mash in there, and as a matter of fact, most of these deeds are not detectable generally. So victims, who all are the victims? So I have tried categorizing them into different sects, we can say. Courtesy to omnipresence and ease of access of wireless. Yes, those were the buzzwords most of the times when used by .11 advertisers to have that thing absorbed, or that technology absorbed into the market. Yes, these are some of the devices we usually find where wireless is usually enabled. Mobile phones, cameras, printers, gaming consoles, laptops, desktops, and more places, more and more things which are enabled with Wi-Fi are the victims here. Another category. Though this category is not much thought about or thought upon, this is equally important. I have mentioned it as a perimeter generals because when your perimeter is secure, your client feels like, yes, my perimeter is secure and I can have some sound sleep in night. But what if there is a hole in that perimeter, and that hole could be due to a wireless network? UTMs are purposely mentioned just to reduce the verbosity. It means unified threat management, maybe IDS, IPS, firewall, whatsoever you call it. In late 2013, there was some vulnerability reported in Wireshark. Now imagine packet analyzer is a very basic concept we use in most of the intrusion detection systems or intrusion prevention systems, and there is a buffer of a vulnerability found into that particular packet analyzer, and your whole architecture is collapsed just like a cards bungalow. So all in all, many victims awaiting an exploitation. So I'll just give you some introduction upon .11 modes. The 802.11 hardware can be operated in many modes: managed, ad hoc, master, and monitor. For this talk, we are taking in account monitor mode. Rest all of the modes are addressing a particular functionality, wherein monitor mode is a mode which is more parallel to, we can say, promiscuous mode in .3 networks, 802.3 networks, though not exactly equal, but it serves the same purpose. So some basic definition again, stumbling and sniffing. I have actually inherited this slide from Kismet presentation given by Dragon. Stumblers are the applications which query the card firmware to see what networks are detectable in the local radio periphery. Positive point in that scenario is like they don't require any special driver to be installed. Well, negative point on that part is like sees less number of packets, sees less number of networks and cannot actually capture data packets. Where in case of sniffers, we all are aware of TCP dump, Wireshark, Kismet and whatnot, capable of capturing almost everything that is available and readable by 802.11 standards. So scanning, in our topics context, scanning is nothing but we are trying to discover the presence of access points into the local radio periphery. Well, some basics on scanning, like what we actually try to do when we scan a particular local radio periphery. We try to read about probe requests and responses. As Abhijit have told, like most of our devices, they save history of the networks, right? To which all networks we have attached prior to till date, we can say, right? So probe requests are actually such requests who sends a gratuitous packet, we can say, into the air and asks like if this network is available for connectivity. An attacker can actually take advantage or can gain an intelligence out of such probe request and can build his own rogue access point using one of the SSIDs being flaunted into that probe request. And that is where he will use that as a response and can create some mess again. Beacon frames, these are basic advertising frames used in 802.11 to advertise presence of an network into the local radio periphery. So combination of probes and beacons will actually create a lot of mess. So here I'll hand over to Amrita to just dwell upon a little bit about Evil Twin attack.
Evil Twin is the core part of our discussion. Here is a little bit of overview of that what we'll be seeing in this topic. That is, who is Evil Twin, some terms, where to find them all together, some boring text, then stats from Black Hat US, Black Hat DC 2010, Mike Kershaw, Aka Dragon. He's also author of Kismet. He said in his presentation that defending clients on OpenAP is very hard. We tried understanding this statement in more depth, and eventually we happened to make the wireless predator, the Evil Twin. So let's picture do the talking instead of any verbose output. So here you can see this is a user who is connecting to a legitimate access point and with an SSID called manu. The blue link here you can see shows that this is a trustable source. It shows a trust that this connection is not vulnerable, presumably. Now just see the difference. there is someone else. There's someone else coming in between the user and the legitimate access point. Maybe an old villain re-entry. So this rogue access point, he is actually taking the traffic from the user, messing up with the data, messing up with the traffic in whatever way he wants to, and then sending that traffic to legitimate access point. Technically, rogue access point is not allowed to sit in between user and legitimate access point, but he is. So this is a small overview about what exactly Evil Twin is. There are some terms related to Evil Twin. So in this diagram you can see that the device here is access point, which has an service set identifier, and just for the namesake we have given the name as manual. So this is an service set identifier SSID. This is a user. In technical terms it can also be called as station or host or node. Where to find them all together? In our previous slide we have seen the diagram, which is a very basic implementation of Wi-Fi networks. This doesn't have any pass keys or any security password. So this can easily be found in airports, cafeterias, hotels, colleges, libraries, offices, and whatnot, many places. Some boring text on Evil Twin, but Rushikesh might make it interesting for you. So I'm handing over to Rushikesh.
All right, let that boring text be boring, but let's find the interest out of it. Some basic definitions. A phishing Wi-Fi AP that looks like a legitimate one with the same SSID. Yes, there are many parameters actually can be replicated in case of Evil Twin. It could be SSID that may be replicated. It could be even MAC address, as most of us are security professionals. We are well aware, like the myth we learn in book, MAC address cannot be changed. We keep on tampering that almost every day, right? We can change the MAC address, and the same thing can be done by even an Evil Twin attacker as well. So typically occurred near free hotspots such as airports, cafes, hotels, and libraries, whatnot. Well, these things are, these types of attacks are hard to trace just because they can be launched and shut off suddenly or randomly and last only for certain amount of time, certain small amount of time. So that makes it again more difficult to trace. So there would be an obvious question coming in, like why so much of concern for this particular Evil Twin attack? February 1st, 2014, this was the news I found into the one of the leading newspaper of India, saying that one of the spy agency was spying onto the air travelers, the people who are traveling through airplanes, while they were accessing internets onto airports. Now imagine a scenario where you are actually accessing some internet onto some airport and you are being spied for no reason, right? So that makes it a little insecure. That was the context where it was international, where it was one way. Second approach. These are some of the statistics from Black Hat US 2013, one of the Kumbh Mela for information security professionals, we can call them, right? So these statistics have been recorded over the time frame of 24 hours. Number of legitimate devices found, 1300. Number of users found who are actually attending only keynote sessions, with 3500. And now, the number of rogue devices found, 1900. So don't you feel this would actually create some concern? Yes, it is. There is some report I have read about this particular figure by Airtight Networks, which speaks on the questionable appearance of rogueness. Like what has to be actually defined as rogue? Well, we will not dwell into that thing, as Abhijit would be the proper person to speak on that. So these are two things which can actually make us more concerned about the Evil Twin attack. So this was the approach we have tried devising. We call it as a first packet approach. Some definitions again. So what is fuzzing? Fuzzing is basically injecting a particular arbitrary input into maybe in any functionality or maybe in any program, and if the behavior of that program is abnormal, then we call the fuzzing is successful. Some more technical definitions I have tried import from Wikipedia and OWASP. Some assumptions we have made for our experimentation, that a host wireless network interface card is up and tuned on to monitor mode, packet injection is working, host has acquired an IP address on the suspected access point's network. So some parameters we have tried to fuzz into packet. So here you can see basic TCP packet. I have imported this slide from Nmap documentation. So the first parameter I have used was fin, the fin flag from TCP packet. Another parameter I have used was checksum. So I have tried to cook something using both of these things, and I have used SCAPI. SCAPI is a basic implementation, basically it is an implementation in Python, maybe a module or library, but I have used it as a tool which can actually manipulate, build, write, inject a packet for me. So more information on this can be found on philbeyond's blog or maybe at secdev.org. So what did we use out of SCAPI? Some simple commands we've used. So initially we have trained SCAPI to read, write and inject onto a particular mode, that is monitor mode. For namesake we have put it here mon0. So conf.ifs is mon0. Now SCAPI will be listening, reading and injecting onto mon0. Then we have written an IP packet where destination we have put it as IP address of a suspicious access point. Okay. And then we have put the checksum. This is again a forged checksum. So I have put it as a 1, 2, 3, 4, wherein the legitimate checksum may be 4, 5, 6, 7. So we have forged the checksum here. So we have actually clubbed this packet with another element. We have clubbed this IP packet with a TCP packet actually, and there again we have forged the checksum. And here we have set the flag for fin, that 0x01 actually indicates fin flag. And again you can see that legitimate checksum is something different shown there. So bad checksum and fin flag we have combined together. The results found in this scenario, so this whole thing, bad checksum and fin flag compiled together, this packet was sent to legitimate access point as well as sent to rogue access point or evil pin. In case of legitimate access point, we immediately receive RST, that is reset. And in case of rogue access point or evil pin, we did not receive anything. We've actually used the same old scanning logic here. Like it should have actually received RST in both the scenarios had there been a proper implementation at kernel level. But there seems to be some mess in case of rogue access points behavior. So every time you send this particular prepared packet, it is not answering anything. Where in case of legitimate access point, it is answering RST. It should have answered RST just because there is no TCP three-way handshake initiated. There is no SYN, SYNAC, AG been initiated. So an arbitrary, an unsolicited FIN packet injected should be answered with RST or should be dropped, right? But that is what is not happening at rogue access point, and somehow the kernel is not behaving the way it should through an access points concern, I must say. So that was our approach. This approach is unique just because, not unique we can say, but this is different because we are using, this is a user who can, we are giving a capability to inject this packet onto access point. Usually the approaches defined so far, majority of them are from wireless network administrator's perspective, or where it has been assumed that wireless network administrator is taking care of such evil pins in the periphery. So here I'm trying to share something that while experimenting these all things we came across many issues. You might love to listen that it took me 2 weeks to even tune on my wireless card onto monitor mode. It was the scenario that I was unable to import that properly into the virtualized backtrack, and it could not work somehow. But it took time, and finally we came to know, like, yes, this is the way we can actually tune on monitor mode onto the virtualized environment. Then at the same time we have compared the performance of virtualized instance to the live backtrack, and we found that live backtrack is performing far more better compared to virtualized instance. The reason being, in case of VM image of backtrack, we could not find all access points into the periphery, wherein there is increase in the number of access points discovered in case of live distro scenario, we can say. So that actually led us to continue experimentation with live live backtrack distro instead of virtualized environment. So another thing, alpha cards, definitely they work great, but as a matter of fact, I have tried this laptop, it has got some Intel 1030 chipset, and even that worked perfectly for injection and monitor mode and everything that is required. So those who all just wanted to start working, or rather want to have something done in this domain, I would suggest them like you start using your hardware first. Many times that serves the purpose. And yes, there is another card we've found that worked properly, was that is Cisco Linksys WUSB045G. So that device again does the same thing. It does the injection. It works on monitor mode perfectly. And yes, all in all, it was a good experience. Yet another way to understand wireless networks. So there is some related work. As I have said, like there are already approaches existing onto this particular detection mechanism. Amrita will dwell upon them a little bit.
Yes, there are certain approaches available, and we'll be discussing them in detail. So we have actually broadly categorized them into two approaches. One approach is which are using RF monitoring as their prime method. Then another one is wired and wireless connection consideration. So first we will see RF monitoring. RF monitoring again has three different approaches. In the first approach of RF monitoring, the user actually monitors RF and gathers information at switches and routers. Then compare them with the same authorized list. A tool called Ad Defense uses this mechanism and scans internet RF and compares the fingerprint. This is the second approach. In this approach, where dedicated sensors are used for scanning, they usually use the parameters like SSID, MAC, and location information. The information collected by these parameters are compared against a verified list. Then the third approach, in this approach, the access point sends a verifier packet, and if received by the internal sensor, AP is internal and hence the evil twin. This is the source from where we have collected the data from. Then this is wired and wireless connection consideration approaches. Rushikesh will be describing this approach.
Well, yes. RF monitoring on one part is really good idea to detect a particular presence of evil twin, but that is again there could be another way also. Some researchers tried devising certain approaches using time paradigms, timing parameters, which are usually available with your all types of frames and packets. So here there is something they have tried to do, like checks connectivity. It is it wired, wireless? I mean, they have actually tried to do simple calculation from host to wireless hotspot, from wireless hotspot to wired. So this is the time they tried calculate. And in case of evil twin, this time was found to be larger compared to the legitimate access points implementation. So the parameters they take in account are round trip time, entropy, etc., and they statistically analyze those all things, and conclusion has been found. Another approach, they calculate the clock skew. Jana Casera, a researcher from some university in US, I don't know exactly the name of that university, she have dwelled upon this approach where she have tried to calculate the clock skew of an access point and build the relevant fingerprint. Again the same verified, list verification has been done and the requisite output has been found. In the third approach called ED sniffer, this research has recently been completed in 2013, October 2013, by Yang et al., researchers from Texas A&M University. So they have used the same mechanism of round trip time, wherein they have used certain learning algorithm in order to zero down upon evil twins. So next approach. In case of Yang et al.'s work, the issue was they were again considering that there is only one hop between a host and the wired connectivity, wherein if we take in account a particular work, if a particular establishment, something like extended service sets, then there would be more than one hops where an attacker might be pitching into, right? So at such places, Yang et al.'s work cannot suffice the need, and here is where the Wi-Fi hop came into the picture. This research has been done by Monica Carlos, a Spanish researcher. So she have prepared a watermark packet and sent it over to the server, some server or maybe internet you can call, and listen on to the channel to find the existence of the watermark packet. If the existence has been found, then the evil twin has been detected. Now this actually overcomes the problem of multiple hops. So all in all, why we need one more approach? Existing approaches are there are many approaches. Majority of these approaches are from admin side, as we have said. So most of these approach, again, they implement certain specific hardware which may be rare to find or which may be difficult to implement, and may require a specific setup as well to make that particular detection work. And sometimes it might require some highest level privilege which may not be always available with the user. The approaches existent are initially designed by taking in account wireless network admin, as we have discussed already, and not normal user. So our approach provides a user side solution for this problem, works on the NIC usually found onto most of the laptops, and uses KP. If you're taking in account backtrack or some Linux distribution, most of Linux distribution supports KP out of the box. So potential approaches, yes, there are many approaches which could be built upon for this particular detection mechanism, like IGMP and BGP, basic protocols which advertises a lot of routers or intelligent network devices into the periphery. They can actually they can actually help us building more intelligence about the networking devices present into the periphery. Then we can drill down upon them in order to find like which could be the legitimate and all. That is just a pitching in statement I am giving. There could be or could not be approach available. Maybe use of techniques similar to traceroute to know the wire transfer time and then exclude, subtract them to minimize the noisy effect at wired side. Yes, as we have been speaking of wireless and wired connectivity consideration, this might actually help at that particular level. One more thing that we are yet to work upon is mobile implanted Wi-Fi tethered hotspots. Because usually we find that such Wi-Fi tethered hotspots are available with most of the Android phones nowadays. But then how to actually separate them from a legitimate or rather a true evil twin is still a challenge. We are yet to work upon that. So conclusion, we have proposed an investigator packet, malicious access point nailing utility, which in response from access point will deliver the result whether the access point is legitimate or rogue. With an economical mundane setup, a normal user is able to detect evil twin. No specific admin access rights are needed. Along with the proposed approach, we have been working on few more approaches. The complete work is submitted for patent and is under procedure. Acknowledgement. Yes, I have been referring a lot of literature, and I really want to say thank to them all. Vivek Ramchandran, I remember Club Hack 2010, he distributed wireless security mega primer, and that actually gave me a very strong insight onto wireless networks and then on wireless security. Josh Wright and Phil Biondi for helping a lot on SCAPI mailing list. Lauren Booty for his fantastic article on Wi-Fi fuzzing. Michael Osman, not directly onto wireless security, but clearing my concepts onto wireless networks. Dr. Kulkarni, he happened to be my guide for my master's thesis, allowed me messing up with n number of devices, allowed me breaking into n number of networks, never restricted me. And Dr. Ranade, who helped me inside out, right from funding to putting me in place. So I just wanted to thank them all, and I just want to thank you all as well for playing a wonderful audience. Thank you.